Good evening. Thank you for joining. In this lesson, I'm going to demonstrate how to configure and verify EIGRP. EIGRP is a routing protocol. It was developed by Cisco, but is now an open standard. EIGRP comes in two flavors: Common EIGRP and Named EIGRP. For this lesson, we will be configuring Common EIGRP, as it's still very common and you could bridge your knowledge gap into Named EIGRP with ease. The administrative distance of EIGRP learned routes is 90, unless EIGRP routes are exchanged between different autonomous systems, and then the administrative distance becomes 170. For this lesson, we'll just be configuring the same autonomous system on all routers. So EIGRP stands for Enhanced Interior Gateway Routing Protocol. As I said, it's a Cisco proprietary, and it's widely used in the industry, specifically around Cisco devices. The purpose of EIGRP is to allow routers to exchange routing information and form a loop-free topology where only the most reliable route is used to reach the destination network. The prerequisites of this lab are going to be that we need to configure R1, R2, and R3's transit interfaces, or just simply the link between R1 and R2 and the link between R2 and R3. After we configure those interfaces, we will configure EIGRP on each of those routers. We will set the autonomous system, and we will be adding the network statements into the EIGRP routing process, so the routes could be discovered by other routers. At the end, we will validate the neighborship and the routes that are learned. As you can see in the topology, I have loopback interfaces on each of these routers. These are simply a way to assist us in this configuration. The loopback interfaces are virtual interfaces, but they are no different to the routing process as a network with client PCs would be hanging off of it. To save resources, it's easiest to use loopback interfaces. Often loopback interfaces are used for testing, labbing. They're also used in other various configurations on Cisco routers, which you'll learn over your studies. So as you can see, I have Class A networks on router 1, Class B networks on router 2, and Class C networks on router 3. What I forgot to put in the topology right here is that the links between R1 and R2 are Class A networks, and they will be 10.250.250.0/30. And this link right here will be 10.250.250.4/30. So I'm going to get started here shortly. So as you can see on the screen, I have the console up on each of the routers. Router 1 is to the left, router 2 is in the middle, and router 3 is on the right. I will start with router 1. I do have my commands scripted. So the first command I issued was the interface Ethernet 10, and I set an IP address of 10.250.250.1, and that would be this LAN interface right here on router 1. You can see I made it a /30 subnet, and I also issued the no shutdown because routers interfaces are shut down by default out of the box, where switches are up by default. So I'm going to move on to the second router, which is router 2, and I will configure that interface. That is complete.
So interface Ethernet 10. The IP address is in the same network as router 1, 10.250.250.2 for this router, and it's a /30. Since router 2 has two interfaces, one facing router 1 and one facing router 3, I do need to configure router 2's second interface. And that interface is Ethernet 11, which gets the IP address 10.250.250.5 with a /30. This will be a separate network than this network here, as the /30 will end at 3 as the broadcast, 4 would be the next network ID, 5 would be the first available on that next network. So router 2 at this point is completely configured. I'm going to move on to router 3. Router 3 is configured at this point. And for a phased approach, it's always best to test layer 3 connectivity before you move on to any other configuration. So on router 1, let's see if we could ping router 2. All right, as you see, it's successful. The first one failed as the ARP process took place. Since R1 was able to ping R2, I know that R2 can ping R1 because it did have a return path back. So we do not need to test that. However, on router 3, we should ping router 2. As you can see, the same thing again. The ARP process caused one of those pings to fail. Once the ARP resolution took place, the pings are successful. Now, at this point, it's good to demonstrate that although these routers are connected together, it doesn't mean they could all reach each other. They could each their directly connected neighbor. They cannot reach a downstream neighbor. So as an example, from router 1, can I ping router 3? I cannot. So this is the challenge that we need to overcome with EIGRP. We can either do static routing, which is an administrative challenge as the network grows. So that's where we're going to rely on a dynamic routing protocol to exchange these routes between all these routers. So the next step, what I need to do is configure the loopback interfaces on each of these routers. And as I said, these loopback interfaces are just used to create a network or simulate a client behind this router. So I've had this all scripted out. As you can see, I created a loopback interface. It's loopback 1, loopback 2, loopback 3, and 4. Each of those loopback interfaces reside in a network that's a /24. I will do the same on router 2 next. As well as router 3. Let me correct my script here, as there's an error in it. There we go. Let's validate the loopbacks are all correct. So show IP interface brief. As you can see, they are up. all 4 of them, and they all have IP addresses. Router 2 is the same. And router 1 as well. So at this point, the next step is to configure EIGRP. On the first router, I will configure it without the script. For the additional routers, I will use my script. So first, you need to do router EIGRP, and this is where we're going to set an autonomous system. As you remember, I talked about administrative distances, and the administrative distance is 90 unless it's from a different autonomous system. So in this topology, we're going to have all of the same autonomous system. We're going to use 100. Okay, we have enabled the routing process at this point. Now we need to set the router ID. The router ID looks like an IP address, but it's just a number. It's very common to use the same IP address that you use on one of your interfaces, just for simplicity, but technically it's not an IP address. No auto summary is so all the 10 networks or all the class A, B, or C are not summarized. They're actually the variable length subnetting is used as these routes are learned. So this is the first command that pretty much you will always issue unless you have some unique situation. And then the last portion I am going to copy and paste. But what we need to do is, looking at all these interfaces, we need to tell EIGRP that these networks all participate in the EIGRP process, including the network that the neighborship is going to be learned over. So here is my script of that. This top one is the link between router 1 and router 2. And then these 4 are the actual loopback interfaces. At this point, router 1 is complete. I'm going to move on to router 2. And on this one, I'm going to copy and paste the entire script. Okay, router 2 is now configured. And as you can see from the messages, we do have a new neighborship, which is great. Next, I'm going to configure router 3. Router 3 is now configured. As you can see, it also has a new adjacency for neighborship. Okay, so now clear the screen here. Now we know that all routers have an adjacency, but let's see what routes router 1 has learned. Okay, D is for EIGRP, 90 is administrative distance, and router 1 now knows that the loopback, those networks that the loopback interface resides in, knows how to get to those networks.
It also knows how to get to networks over on router 3. As well as the transit network between router 3 and router 2. And these are the directly connected ones. So now, if we were to reissue our ping that failed before, you can see we have 100% success. We can also ping one of the loopback interfaces. That's all successful. For ease, I just incremented the third octet for each of those networks, so these will all succeed as well. Perfect. For verification, we could go to show router 2, or we go to router 2 and show IP route. And this one we could filter it a little more. So we just want to see all routes from EIGRP. On the first router, you may have noticed we did show IP route, and the output shows all of the locally connected routes as well as EIGRP. So for a cleaner view, you could do show IP route EIGRP. And on router 3, we have the same output. So router 3 will have full reachability to the loopbacks on router 1. As you can see by the ping command there. So some useful commands before I end this video is show IP EIGRP neighbor. This will tell you if you have a neighborship with a EIGRP router on the same network segment. Another one is show IP protocols. And this tells you right here, we are learning routes from these sources. If we had multiple neighbors on this segment, we would have multiple routers that we'd be learning these routes through. You could also see that the networks R1 is routing for are these networks. If we had forgot to put the network statement under the EIGRP process, you would not see these present here. So that wraps up this lesson. I hope this was helpful. Thank you very much.